In problem 3, as well as all the other problems, we're trying to figure out some details in analyzing the graphs of these functions. And the first two parts of each of these, we're trying to figure out if the functions are increasing or decreasing and where. So in starting from the left, I'm going to use the colors red and green to indicate kind of like red light, green light. Red is negative, green is positive. Okay, so let's think about that for a second. When you see red, that means the graph is going down. When you see green, it means the graph is going up. So what we look at here, even though we see an arrow going up, what that means is that, yes, the arrow, the graph does go up forever, but from right to left, it goes up. But when we read a graph from left to right. So we know that it goes on forever there, but if we were to start on the left-hand side, we would see that as we move from left to right, from negative infinity all the way down to -2, we would see that the y values are getting smaller until we hit that point right there, until x gets to -2. As soon as x gets to -2, notice that the y values start getting bigger until we get to x equals 0. And then again, the y values, once we get to 0, the y values start decreasing again. The y values are decreasing on that interval. And then as soon as we get to 2, the y values start increasing again, and they increase forever. So then how do we write these intervals then? So we say that the function f of x is decreasing on this interval from negative infinity to -2. So we get from negative infinity to -2, as well as from 0 to +2. So we say the function is decreasing on those intervals where we see the red. On the other hand, the function is increasing where we see the green, from -2 to 0, as well as from 2 to infinity. So that's how we take care of the increasing and decreasing. Then we want to identify the x value for which the local max and mins for the function. So we have a local min there, the x value of -2. A local max right there would be x value of 0, and a local min right there where the x value is 2. In fact, these are not only local mins, but those are also absolute mins. There's an absolute minimum value of looks like -10 on this function. There's no absolute maximum because the y values keep getting bigger. Here we have a local maximum, but we have absolute minimums. But absolute minimums are also local minimums, because to be a local minimum, you just have to be the lowest point of all the ones kind of right around you. So the highest point right around you, then you're a local max. Lowest point right around you, then you're a local min. Okay, and then what are the x-intercepts, if any? Well, we can hopefully clearly see that there's an x-intercept, looks like about -2.5, 0, and 2.5. So I'm going to just put the x-coordinates there. -2.5, 0, and 2.5. What's the domain of the function? Well, the domain is all the real numbers, x, that you use to graph the function, the lowest x to the highest x, and if there's no breaks in between, then we have a domain of all real numbers. And the range would be all the real numbers y from the lowest y to the highest y minus any breaks in between. So we're using all the y values from all the way from -10, including -10, to infinity. So we always read the range from bottom to top when we read the domain from left to right. And then, but I didn't realize that part G is asking for the absolute maximum minimum values, if any. Now the value, absolute min value, would be, like I said, -10. It's the lowest y value on the entire graph. Absolute min, -10. And there are no absolute maximum values because the y values keep getting bigger and bigger, and there's no one real number that would be the absolute maximum value. And remember, when you see the word value, whenever you're asked for values, unless you see an x in front of it, values automatically implies y. So if it says x value, well, then that's an x value. But if it doesn't say x value, then it's implied that that's a y value, because the value of the function is the y coordinate at any point. And so hopefully you've got that straightened out.